Hello, everybody. Welcome to the second webinar on Git. So in the first webinar, we covered basically the local aspect of Git. So creating your library, your program, doing a little bit of branching, doing some branches, making some commits. We went over the Git model, mental model to keep in your head. And then that filled up the hour. So now in this second series here, we're going to do more of the collaborative online work. So if you recall correctly, or if you've rewatched it, the prior series, it's on YouTube. This is where we were at here. We had our commit, our initial version here down at the bottom of my little history graph was a Hello World program in Python. And then the functions version, we modified that Hello World program in order to add, to put the Hello World into a function. And then we did two separate development branches. So we split here. In the first one, we added MPI functionality. So it was a basic Hello World that would print Hello World from process 1 of 2 and 0 of 2. And then on the other one here, we converted it into a library. So we handled the initialization correctly if it was imported versus if it wasn't imported. And then finally, we brought those two back together. So we brought in the library modifications to the MPI version. And along the way, we uploaded it into the local SHARCNET Git Lab server. And we viewed it there and showed you some of those items. So, and this was our overall picture of how Git works. So on the left, we had the object store, which was basically the Git database, and that's where it stores all your versions. And the important thing, the object store is Git only adds things to the object store. So your data is, if it's been committed into Git, it's here in the object store. It can be a little bit difficult to get it out if you're not familiar with some of the ins and outs of Git, but it's very safe. Now, this here was the staging area. This was where we put together the next version. That was a little bit different than some of the traditional version control systems where your next version was always your directory. But Git has this additional functionality because it was created by Linus for working with the Linux source tree, and the putting together the next version can be very complex, especially you have a lot of files and you have some parts you want to add and some parts you don't want to add. And then finally down here at the bottom was the folder or the working directory, which is just the directory on your computer. And then when you start, you can also tell your local Git about other Git databases up in the cloud, and that brings in these remotes, and then it can fetch stuff back and forth between, share data between its local database, which is on your hard drive, and the other databases which are on other people's hard drives or in server hard drives and so on. And then most of these operations here are just the basics of moving data between them. So you, first of all, you just have your folder, you run a git init to create the initial version, and then that adds the rest of the Git stuff, so the staging and the object store, and you add your items, and then once you're happy with your next version, you do a commit, and then that creates the first version here. And then you can run these difference commands to compare and contrast where you're at. So all that sort of stuff was covered in the first talk, and I won't be going over that again. On this talk, we're going to pick up with where we left off as a different user, so we can focus on the collaboration. And I'm going to act as the user we have for our laboratories, which is just Lab 01. And I'm going to sign the Git Lab here using this lab user. So I should, I guess, add at this point here, there is GitHub is the most common online repository, Git repository you can use, and you're welcome to use that. And it's very similar to what we're going to be showing here. Git Lab is an open source one, and so we run a variant of the Git Lab server for our users. And the advantage of this one is that you can create projects and keep them private. If you're going to do that under the Git Hub, then you have to pay for it. The disadvantage of this, of course, is we don't have near the reach as the GitHub. So if it's an open source project and you don't care, then put it on GitHub. That's probably the better place for it. That'll get a lot more exposure, a lot more other people will be involved. But if it's you have a local team, and you just want your local people using it, you want that privacy option, then use our server. So here I've logged in as the Lab 01 user, so it's always just your username, your SHARCNET username, and your SHARCNET user password. And this brings me in. You'll see something familiar. This user hasn't had anything set up yet, so you can create a new project, you can set up a group, you can browse the existing projects. And then if you click on this here, so up in the upper right, there's a little icon, and that's where you can set up your profile. So profile settings, I can upload an image that'll be associated with me, can set my email, whether it showed, and put these other links in. And I can sign out. On this side here, you have the drop-down menu, and these are the top-level menus, so you can look around. There's not much happening with this user since it haven't done anything yet, but let's pop over to the projects. So they don't have a project. Let's browse the existing projects. So this here, there's a variety of projects on the GitLab server, and if they're set to internal, which means only shown to visible users, then you'll see them. Or if they're open to public, you'll see them as well. So the traditional program that everybody is interested in is the Hello World program. So say this user here is going to say, okay, well, I'm going to get started in programming. Let's see what we got for Hello World programs. And we can see, indeed, Tyson Whitehead has a Hello repository that is open to other GitLab users. And then there's these various other people who do as well, who created them, I presume, while they were watching the first demonstration. So let's have a look at Tyson Whitehead's Hello program. Now I've clicked on over here, and you can see it's saying you won't be able to push or pull via secure shell until you add an SSH key to your profile. So if you don't have an SSH key, then you have to keep entering your username and password, which gets a bit tedious. So we'll cover adding an SSH key at the point when we decide to start doing that, pushing and pulling, that is. So here's the project. This is if Tyson had added a README file, I would see it displayed nice down here. So that's a great way to put a sort of a summary about the project. I have a couple options across the top here. I can have a look at the activity and see this is activity with respect to GitHub. I can click into the repository and I can see, oh, there's a Hello Python file. I can look at it. I can see the code. It's nicely marked up. Let's go back here. I can click and see what versions there are. So there's the two branches we saw on the right. Actually, let me just move this over here so we get a better picture of that. So there's the MPI and the master, and I had uploaded those both. So here they are for this user as well. So we can click over to the MPI branch, click on that, and we see here's the Hello World program, which has got a bunch of MPI calls in it. I can have a look at the network. Is a very nice feature here. It just sort of gives me a graphical picture of all the changes that have been saved. And this is basically what I'm seeing on the right here again. It's just GitHub is graphing the changes. I can get this view here of the branches as well. I can get some graphs about contributors, commits. So this is just sort of history. The number of the percentage of the code by language. It's all 100% Python, this one. Issues, we can open some issues, so it'll do issue tracking. And there can be an internal wiki associated with it as well. So if Tyson had created a wiki, I could see it here. So we're thinking, yeah, this project doesn't seem too bad. I'm liking it. So I'd like to check out the source code so I can run it on my computer myself. So if I go back to the main project page here, Here's the URL I can tell my computer about, and you can notice there's two here. I can get the SSH, which will require setting up the SSH key, or I can get the HTTPS. So for now, we're just downloading, so we're going to stick with HTTPS. I just click this here to copy it to my clipboard, and let's go back over to my computer. So our next Git command we're going to learn, building on the ones we've already learned from the first session, is the clone command. And this is the command, if you're not actually doing any development yourself, you'll probably find the most useful. And what this does is that attaches up to the remote Git repository, which in this case is in the cloud at this web address, and it downloads the thing and makes a local copy for you. So there we've cloned into hello, it says, and some statistics, and I see, oh, now there's a hello directory. Let's go into this hello directory, and there's the hello py file. And let's open that hello py file here. There indeed is the program. And we can run it here. Let's just run it so we can indeed see that it is. So Python hello py, we do indeed get the hello world. Now, one thing you will notice here was there was actually two versions when I was looking at it in the cloud. There was the MPI version, and then there was the non-MPI version. So what if I want to run the MPI version? Well, by default, you get what's called the default branch, and I've set up the hello world, so the default is the master branch, which is the non-MPI. But when I downloaded it, I got both of those, so I can still check them out. Let me actually just pop over to my diagram here and add the two Git commands that I haven't discussed yet before up at the top. So if you're creating a Git repository by yourself, there's the clone command. Well, first of all, there's the git init command, which just sets up this stuff in an empty directory as covered by the first one. And now we also know there is a clone command. So that's git clone. And then the syntax is just the URL you wish to clone. And if you want to, you notice that it used the name hello because that was the name, the last part of the path. You can override that, so I can put it in a different directory if I want. So again, just to quickly cover this syntax, there's two bits here. There's the bits that are in the angled braces, which means you have to substitute something in, so you put in the URL there. And then there's the bits that are in the square braces, which means they're optional. So you can just say git clone some URL, or you can say git clone some URL, and my directory, for example, will put it in my directory instead of whatever the default is it guesses from the URL. All right, so now let's go talk about this as well. So we've got the master branch. And that's the branch we're on. We covered branching last time. We can look at our branches. We can see, oh, there's the master branch. And actually, our repository is not looking at all like this graph because this is the one from my prior talk. What we actually have in this case is we don't have an MPI branch. We have the master branch. The master branch is in green, so it's the head branch. That's the branch that's being worked on. And then there is no MPI branch showing up. So this is what we're actually looking at. Now, we want to have that other branch. And as you can see from up here, the branch command has a -a option, which shows all the branches. So let's run it with that. And after I've done that, you can see there's actually additional branches here, these red branches in red. And those are ones it knows about. Those were ones that downloaded into our database from the origin. So the origin size has a head branch, which is the master branch, which is why it gave me the master branch by default, but it also has an MPI branch. And the MPI branch is the branch that I'm interested in. So if you recall correctly here, by cloning from an origin, it set up a remote that the machine already knows about. So to review again, the command to view your remotes is git remote, and you can add a -b if you want verbose output. And you can see here origin is just this URL in the cloud, and these are the associated branches with it. And we want to have a look at that MPI branch. So if we want to look at it, we got to create a local branch for it. So we'll just say git branch. We're going to call it MPI, and what commit we want? Well, we want the origin MPI commit. So again, this is just this syntax over here. So branch, the name of your branch that you're creating. In this case, it's MPI, and then where to create it. So we're creating MPI at origin MPI. Press enter there, and you can say it says, okay, MPI has been set up to track the remote branch MPI from the repository origin. And now if we do our git branch, our local branches, we have two. We have the MPI and the master. So in terms of our diagram, we now are up to this here. The green branch is the one that we have checked out. That's where the head is. And then the MPI branch is this one up here. So we want to switch over to that MPI branch. So we'll check it out as we call from our previous command. So git checkout MPI. And what this will do is this will bounce head up to here. So that's the one we're currently working on. And then we can see from the checkout command here, let's just jump out to full stage here. The checkout command here, it'll also put that version into my hello py and my folder as well. Sorry, into my staging and my folder. So it'll change my files. So let's run that, git checkout MPI, switch to branch MPI, and let's reload this hello py program here. So just reload it in my text editor, and you can see now indeed I am on the MPI version. And if I run this program here, I'm just going to unset my display, and that's a technical reason that you don't actually have to run that command, but that has to do with my OpenMPI version and OpenCL. Anyways, so let's run this MPI run number processors 2 python hello.py, and you can see indeed we have the MPI version of the Hello World program. Now, as it so happens, maybe we'll switch back over to the master version. I'm not so interested in this case of running the MPI version as this Lab 01 user. So say Lab 01 goes ahead and uses this program for a while and then thinks, oh, you know what, it'd be really great if it had this additional feature. So they go back over to the repository here. So this is them logged in, viewing my repository, and they're like, well, let's create a feature request. So they go to Tyson's Hello World, and they pick a new issue, and they say, so it would be great if it was more Canadian. And then they can sort of describe what they want. So they say, you know, hello is good, but the text is kind of boring. So it'd be good if you could internationalize it. And a little quick note about internationalization. You'll often see this called I-18N, and that's I, 18 other letters, and N on the word internationalization. Maybe starting with a more Canadian greeting, right? And they say, okay, well, that would be an issue, so they submit that issue. And they have opened this issue. Now, let's bring over another browser here. Here is me. I'm going to log into the Git Lab server. As the person who created that, I log in. And then I can see my projects. I have a variety of projects. I have the hello, and I've got this little to-dos up here, which pops up my list of recent to-dos. So let's have a look. Go have a look at my projects. If I go back over to my projects, and here's my Hello World project, I can now see there's one issue. And it will have actually emailed me about this if I have set it up to do so. So now I can click on this issue, and I see, oh, okay, look, Lab 01 opened up this issue. It'd be great if it was more Canadian. And I'll read this, I'm thinking, yeah, I don't know if that's really my sort of priority. So being an open source project means I give the typical open source response, which is patches welcome. In other words, yeah, if you want to go do that and send it to me, I'll add it in. So we just throw that into a comment. And then we go back over to this person here, and I'll just press the F5 to refresh their screen. And then, I mean, again, they will have got an email about this if they have set it up to email them. I see they say, oh, Tyson Whitehead said patch is welcome. So in other words, Tyson's saying he's not going to do it himself, but maybe it's something you want to look into. So, and maybe that is something. So the user's got their code here, and they're like, okay, let's try and do this. Let's try and add some internationalization to this. And we'll just add it to the master branch by default, because we're not going to want to get this more complicated than we initially need it to be. So the internationalization program is relatively straightforward. It's a Git text library. It requires a little bit of initialization. This is, not actually that relevant to this particular talk. The details of this is because I just picked this as an example of something. And then basically you wrap all your strings around with this underscore function, which goes and looks them up for an alternative translation depending on what the lang setting is. So that's the basis of the code as an internationalized code. And if we just run it, it won't actually look that much different. It's still saying hello world, because we have to add some translations. And I should add here, my language by default is set to English Canadian and the UTF-8 encoding. So let's say we want to add a Canadian version. So we'll make an English Canadian directory. And this, I mean, part of the reason I chose this example is I'm going to finally add some additional files into here as well. So we won't just have a one file program. And then there's an LC messages directory under it. And this is just all part of the whole how the whole internationalization thing works. And there's a program you run called the xgettext. And basically you just give it your source code and it goes through it and it identifies these sort of lines that you've put in to extract out those bits of text. And then there will be a messages file here. And then here, basically, you can see here's the message ID, which is the default string, which is the hello world. And then in here, you can provide the alternative. And this comes up in Emacs under some sort of special editing mode. So I'm just going to turn that off. By just switching it into default text mode. All right. So say as the Canadian version, we're just going to add an A on that, right? Hello world A. It's sort of a Canadian thing to do. Now the context type, again, this is just internationalization stuff here. Put it in UTF-8. The last translator, well, that'll be me, lab08 at sharknet.ca. I don't know, whatever we want to call SHARCNET Lab 08. The revision date, well, we'll just say that's the creation date as well. And there is our translation. So if there had been more of these strings here, then they would show up under here, and we'd just do them one by one. So you can imagine we could be if I was any good at French, I could be, putting together a French version or a Russian version or a Chinese version. Well, I'm actually not sure how I would do the Chinese version since the character sets are substantially different, but I'm sure you get the idea. So we've ran it then. So let's go back over to our text here. And then there's another program you have to run called message format, which just basically goes through and creates a binary version of this MO version. All right, so now if we run our program, we can see we're getting the Canadian version. And if we unset our language here, so we run it with lang set to nothing, and so lang python hello.py, then we just get the standard text. So if it's not a language it actually recognizes, then it just uses the default here. If it is a language that it does recognize, and by default my language is English Canadian, then it will go and look this up in those files we created. So there we go. We have internationalized this program as Lab 08, and now we want to suggest that Tyson add this feature to his code. So first of all, we're going to have to put it into Git. So Git, if we run the Git status command here, of course Git doesn't actually know anything about this yet because we haven't told it. So we've done two things, right? We've modified hello.py. We can run that git diff version to see, and we can say, oh yeah, we've added the import text. We called this here, and then we put the underscore function to do the translation in front of the text string. And bring that status back up here. And we've created this English CA directory. So well, let's add the English CA directory messages. We're going to add the compiled version. It's debatable whether you actually want to add a compiled version to a repository. Ideally, we'd have some sort of make system here that would handle also compiling these for installation. But because this is a rough and loose example, I'm going to add the compiled version so when other people check it out, they have that already compiled because we don't have a make system to properly build our project. So there we go, get status. Now if you recall from before here, what we've done is we've flowed our new additions up into our staging and our index. So my diagram's actually getting a little bit behind the talk. So let's go ahead and update the diagram here. So first of all, our hello has some additional items to it here. So what we've added here is we've added an English directory, and then under the English directory, we've added a lc_messages directory, and then under the messages directory, we've added a messages.po file, which is sort of the editable one with the char set in it. And then we've also added a messages.mo file, which was the compiled version. All right, and I'll just put a slash here so we can kind of keep. So these are at the same level. And then there's under the English directory here, there's this directory. And then under this directory, there's these two files here. So we'll just put a. So this is what happened after we edited our code. This was in our folder, but our Git repository still knew nothing about it, which if you recall correctly, if I scroll back up through my history, was where we were right here. So we've modified the hello that knew about that because it said, oh, there's a difference between these two. And it says, oh, in this English CA directory, I guess I should correct that there. That should be English_CA, English_. CA directory has showed up, and there's stuff under that we don't actually know about. So then I ran the git add command on these two files, and then they got added up there. So after the git add command, basically this stuff here also shows up here. And so this is where we're at right now. If we run the git status command here, it says, okay, we got the hello pi. Now there's a difference between these two here. And then we've also added English, LC messages, message MO, and messages PO. So we also want to, of course, add these hello, the difference in the hello program. So again, that's our stuff we've added. So we add that to get hello.py. And I'm going to show you just a sort of one of the interesting things about this staging at this point. So if you add the -p option, which is the patch option, and I say git add hello.py, you can see there are sort of two areas here. There is this one and this one up here. So I can say, now it says stage this hunk. So it's saying, do you want to, well, basically it goes through the file bit by bit and asks you for each bit whether you want to add that. So you can actually pick and choose inside the file as well. And so any lines that are close enough together, it'll ask you. And if it doesn't really consider one line by default to be a difference, but I have the option of splitting. Question here will bring up the help on these various options. So I can say split, and now I can go through them one by one. Add this, yes. Add that, no. And now have a look at my git status. Now it's saying, oh, look, you have a modified hello.py, so that was the first part of that addition, and you have a modified hello.py in your directory as well, which is the second part of the addition. So far I've only staged the first part of my addition. And if I look at the git diff, you can see that as well. Now it's saying, oh, the difference between this hello.py and this hello.py is this additional lookup, the verb part, the word part. So I actually want that as well, so I'll just add that in too. And now there are no changes in my local directory that are not in the remote directory. This tilde file is just a backup file Emacs created. So let's do my next version. So we'll git commit it. And if you recall right, git commit here, I'll just zoom out on my message here. We'll take this stage version and we'll put it over here and we'll add it on to the head. So that'll be, I'll get a new version up here of master. So let's run git commit. And it looks like my editor is set to nano, good enough. So you can see why they call it I-18N instead of internationalization. And I've mentioned this before on the sort of commit messages. What you want to do on a commit message is you want to give a sort of a default top-level description of what it is, so internationalization support. And then on later lines, you can add in further detail. And you'll see that a lot of programs only show the first line with the option of expanding it. So if there's a lot of commits, it really helps to sort of just have a summary. So you throw in a summary line, and then the next lines you put in details. So there we go. Currently one provides Canadian. We'll just save this. Save it, yes. There we go. And if we run our git status, you can see it's ahead. Now it's saying your branch is ahead of origin master by 1 commit. And that's because we have created the next version. So let's add that into our diagram over here. So we'll just use the light blue I'm using. So right here, the next version. This version here is I-18N, so internationalized. It flowed out, let's make a nice straight line here. Flowed out from that version. And it was head was master when I committed it, so this becomes the next version up here. Just push this MPI down a little bit to clearly delineate that, and I'll move this down a bit here just so it actually touches. There we go. So this is what we look like now, and you can see the remote side is still down here, which is why it says your branch is ahead of origin master by 1 commit. Use git push to publish your local commit. Now, if I try and do a git push, I'm going to rapidly discover I don't actually have access to my remote, which is Tyson's repository, right? I'm lab 01, so I can't push by default. I can't make changes to Tyson's work. So what I have to do is I have to create a local version up in the Git repository where I can store my changes. So that's what we're going to do next. So let's go back over here to, yes, so this is my Firefox browser, which is my lab 01 person who has opened this up. You know, maybe I wanted to give Tyson a little bit of feedback. So a pull is an official name to pull in some changes. So I'm working on this. I'll request you add it when I'm done. All right, so now I'm gonna have to have a local version that I can save my changes to. So I go back to the project here, and you can see somewhere here there will be an option to fork this project. Right here, fork the project. So forking makes a copy of the project, so I'm going to make a copy of it for myself, and then I will have write access to that. And you can see now it's saying SHARCNET Lab 01 hello. And this is so it keeps track that it was forked from Tyson. This is a demo of the Hello World program. And now since this is my copy, I can update it. So this is very common in these Git Lab and GitHub servers. You know, that person has their version and you work away, and then you use that if you're just using it, and then as time comes eventually you wind up making some changes to it, so then you fork it and you can use it yourself. Now if you know ahead of time that you're going to fork it, you can just fork it right away, and then you can pull from your own version. In this case here, I pulled from Tyson's version and then I forked it. So what we're going to have to do is Git currently only knows about origin, and origin is Tyson's version. So let's also add another remote in, that's my version. So let's go back over this version here, and you can see here's this address as well, Git SHARCNET Lab. Now my version I'm going to actually want to push to, so let's use an SSH version. And then this way here too, I'll go through adding an SSH key. Okay, so git remote add is one of the commands we covered before. Actually, it's just right down here. So we give it a name. Origin's not terribly descriptive. I probably want to rename origin to Tyson. But let's just call it Lab 01. Git add Lab 101, and then we paste in that Git address. There we go. Oh, Git remote to list them. And now you can see there's a Lab 01 and there's an origin. And I don't remember offhand the command to rename origin to Tyson, but I could look that up in the manual page. So if you Google for any of these commands, git remote manual page, git remote rename old new. All right, so git remote rename origin to Tyson. Git remote. So now there's a Lab 01 and there's a Tyson, and if I do a git remote verbose, we can see they are indeed. So Tyson is the old HTTPS one under the user Tyson, whereas the Lab 01 is the SSH one here under the Lab 01 account. So we want to use SSH. So to use SSH, we're going to have to set up an SSH key. And I'm just going to show you the Unix one way of doing it. And to do it under Unix, you run SSH keygen, and it by default spits out a key into there. And you can enter a passphrase. If you use it lots, you don't really want a passphrase. But if you're going to put it on a remote computer, passphrase, basically it's another layer of encryption of the file. So there we go. We got a little image of it. And you can see it saved it in my .ssh idrasa.pub directory. So let's have a look at that. So there's two. There's an idrasa, or depends on what your keys are setting up. You might have an elliptical curve or a DSA, and then a public. So the public part is the part that has to be uploaded to the Git Lab server. So let's just open that file up. SSH. Right. So this is the key. It's just this big ugly mess here. And what you do is you cut and paste that out of there, and you go back over to your GitLab server here, and we click on this here, and we do, oh, actually, I can just click right here. You won't be able to add an SSH key to your profile. So I can do it through here in my profile settings, or I can just click a shortcut here and paste it right here. And it tells you usually contained in the file idrasa.pub, which is indeed the case. So there's my public key. And you can give it a name if you want, add the key. Oh, maybe I have to give it a name. All right, excellent. So there, now it's added up, it's associated with this account, and I'll be able to push it to it. So I'll just tell my local computer to add it into its memory, SSH add, identity added. So now I'm ready to push. So git push. Let's have a look at our remotes. Git push was our push command here. If we go back over to this side, push the remote to the branch. So git push, the remote in this case is lab01. So I can choose between, I mean, if I say Tyson, it'll fail because I don't have permission, but I want to say push to lab01. Let's push the master branch. So the first connection to it here, so yes, we'll call it, you just say yes. There we go. Now it's pushed this up to lab01 hello.git, and you notice it didn't ask me for my password. That's because I was authenticated by that key, which is very nice. All right. And if we go back over to here, we go back over to, let's get back to this projects here, SHARCNET Lab hello1. Demo Hello World program showing off Git, forked from Tyson. We can see there's 4 commits. We now have the internationalization support, and as you can see, these ones have dots. As I said, if there's more than one line, it only shows you the first line. So you want to make your first line a sort of generalized description, and it's also important to make these descriptions should be, they shouldn't describe what the change was. They shouldn't be like, oh, I changed this greater than sign to this less than sign, because that's a textual change. And if I click this button here, you can see Git is happy to show me. The computer can tell me what lines of text I changed. It says, oh, look, you changed this line specifically. You removed this bit here in the darker red, and you added this bit in the lighter green. What it can't tell me is why I made that change. So you want in your description to say why you made that change, because that's the bit of information that's missing. The computer can tell you what line you changed. It even tells you what parts of the line you changed. What it won't tell you is, you know, that fixed some critical bug, there was some memory leak associated with it, what your plans are. Anyways, so here we have this one here. And if we do want to go, indeed, if we pick back on our project here, oops, sorry, our activity. So you can see here's the activity. So first of all, we created it from lab01 hello, and then we push to master. We push this internationalization support, and our graphs here will now be showing. It's not a huge lot of excitement stuff going on in here. Repository, what was I looking for? Network, yes, this is what I was looking for. Here is our graph, which indeed now it's swapped the order of this here, so this is sort of backwards. I've got MPI on the right where they have it on the left, but you can see here indeed are the two histories. All right, so now what we want to do is we want to go and request that Tyson merge this into. So we've got our code there. We want to do a merge request. So we can jump back over here. We can go merge request. I believe there's a nice way to do this from the, there's a nice merge request option somewhere on the main page, but I've forgotten where it is. So hello world. So source branch, hello world. Source branch, we want to ask to master. We want to bring it into, and because it's my email address is set to my Tyson email address is why it's saying this change was made by Tyson. So lab 01, hello, the master branch. We want to bring that into Tyson, hello, the master branch. So we click the compare and continue. And now it says, okay, a new merge request. We can put this in internationalization support. Currently only provides Canadian. So basically it's taken my commit message. And you can add a work in progress, which will mean that there's still more coming to prevent it from accidentally being added in. It's showing the number of commits associated with it. And then I can say, closes, I believe, #1. Yeah, so you can reference issues as well. So I'm saying, okay, this closes #1, which would be great if it was more Canadian. So let's submit this merge request. Or maybe I want to say, yeah, okay, submit merge request. And there we go, ready to be merged automatically. So first of all, it checks to make sure it can be cleanly merged. And in this case, it can, right? There wasn't any major changes I made that would conflict. I just added some lines. So what would happen is if Tyson had went and he had made some changes also to that file, then it might not be ready to automatically merge. So it lets you know right up front whether it can automatically be merged. And we can see issue number 1 here has, because I added that #1 here, it says it's mentioned in merge request *1, so it automatically links that. So exclamation mark gives you a merge request, a pound gives you an issue. So there, lab 01 is all done. Let's go have a look at things from Tyson's perspective. So I'll just refresh Tyson's page here. And now Tyson says, oh, look, here's my project. It looks like we've got a merge request. I can click on that. So I got this issue. First of all, there was more stuff on the issue. Would be great if it was more Canadian, updated. As mentioned in merge request 1, related merge request. Git was requesting to automatically be able to pop up notifications to me, which might be nice. Accept merge request. I can just go accept it. I can dig into the details here if I want. And see. I can download it. I can check out the branch. Or you can also discuss it here too, right? So say I had some sort of concerns with it. I could say, you appear to have committed it as and this is Markdown formatting as well. So you can click on this here. Link will bring you up to some Markdown page help, and you can do all sorts of nice things here, including what they call code blocks. So when you put quote, quote like this, and then the language, and then you put the quote, and then another quote, 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 it comes out all nicely colorized up. So we'll just comment like that. So, and then we could have this whole big discussion. We can go look at the changes here. Here's the actual changes. I can comment on each line of the change. I can say project id version, package version. So I'll say, oops, let me click the comment button here. All right, so you can have this whole big on discussion. They can come back, they can reply. And I can comment on any of the diffs. Anyways, at the end of the day, after a lot of discussion, I'll either accept or reject it. In this case, I'm going to accept this merge request. I think this is a good thing. So I press the accept. And then what it does is it goes and takes their addition and it brings it back into mine. Mine sort of being the official. There we go, merge. So let's go have a look at my repository now. And indeed, if I check out this master branch here, let's have a look at my network. You can see it has now merged their master into mine, bringing in the internationalization support. Now, when I did that merge, there would have been an option back there in order to do what they call a fast forward, which just adds it. But this here actually added another special commit that kept track of the fact that this was merged from their work. Okay, now there's one other thing I want to show you here before we call this done day, and that was, you notice I internationalized the non-Python version. So say I'm going to go back to my lab person here, and they want to internationalize the Python version as well. And the reason I'm going to show you is because I want to merge this internationalization support into MPI. So I want to create a new MPI version here that's the old MPI plus the internationalization. And this is not going to be a clean merge because there will be different parts. The files are actually subtly different. So you're going to get to see a merge conflict is what it's called. So let's check out our branches here. Let's switch over to the MPI version. Check out MPI. That's pretty much all I have to say about using the Git Lab server. You saw how to do issues and stuff like that. So I just want to cover this one more before the end. So we'll switch over to the MPI. We're up to date. Let's merge in the master, which again has an internationalization. So let me just keep my, not get too far ahead of myself here. All right, so we've checked out the master. So what we've got. There's where we are right now. We're going to merge master into MPI. So what that's going to do, we're going to create a new version up here. This, and this version is going to come from that, and it's going to come from that. Git merge master. Click. And then, as I said, here we have a merge conflict in hello Py. We run our status, and you can say, okay, so it's brought in these messages files because they didn't exist in the other, so it's a nice clear thing. But then both of you have modified the hello.py file. So let's reload this hello.py here and see what happens in a merge conflict. So it has changed, so we reload it. And basically what it does is it breaks it up for you. It says, okay, so here is the MPI version. That's the head version. Remember, head is right here. And here is the master version. And I can't figure out what's the proper thing to do between these. So in this case, you have to manually fix it yourself. If we had edited separate lines, it guesses that the right thing to do is add the lines that were added. But when you edit stuff around the same version, then you have to put it together yourself. And in this case, it's pretty easy. We just want to import the get text routine again, as well as the MPI. It doesn't really matter. I'll stick MPI at the front. And then my greeter here, we can see we put this in a brace here, so we're going to have to put this in a brace as well. There we go. So I think that's got it. So what we had done is we added the get text, we initialized the library, and then we put the brace around our messages. Right, so we don't want that, and we do want that. And there, that's the version we want. Git status. Now I say, okay, that's what I want, so I'll add it. And then I will commit. You can see it actually told me to do, I'm just following its directions up here. It says fix conflicts and then run git commit. merge branch master into MPI. That's not that great of description. I could call it something better. I don't know, maybe I want, oh, let's just go with that. And you might want to describe a bit about what you had to do to resolve it. Anyways, there we go. We'll save this here, write it, and then we will exit. And there we are. And now what we have up here is the I18N and MPI and library. Well, let's just call it plus MPI plus lib. And of course, since we did this commit here, the head, which was MPI, has moved up to be this new version. And that's where our Git repository is. And I actually deliberately made a mistake in this case. And that mistake was simply that I did not update my messages. Right? This is message ID is hello, where the real message ID now is this big long one. So if you've realized you've left something out from a commit, you can come along and fix that after the fact. So we'll put that in there, and then we'll put in the Canadian version, which will be the same with just the A on the end. And we'll save that. And now this is the actual correct version. Actually, technically, I still have to run that message format. There we go. Git status, git add. So add all the files with a 2-letter extension. That avoids this one here, which has a 3-letter extension. There we go. Now I want to commit it, but I don't want, really that should have been in this previous commit. And in this case, you can specify the amend option, which brings up the previous commit and lets you recommit it with your new additions. And if we ask for our one line of our log with our graph, we can see here indeed is the graph we have on our right side. So the internationalization and the prior MPI version have become one. And I redid this last commit. Now you should, if you ever push this is what Linus says anyways, if you ever push this up, expose it to the build, somebody else may have pulled it, so you should not go back and start amending commits. This is just when you're doing your personal development on your stuff, and it's still loose and free, but once you've saved it with the world, if you start rewriting some of this history, then when they go to update from yours, it's going to screw their system up. So once pushed, you should not use amend, but before push, you can use amend to add stuff to it. And with that, that concludes what I had want to say, so I'll just zoom back out on the image here, a nice full screen. And so thank you very much for attending the talk.